everyone. So I hope you are in a good mood, in a good health. Okay, because today we are going to discuss or to recap back for topic 3, electric current and direct current. So this is a Latin Omega for series 2 in semester 2 2020-2021. Alright, okay guys. So before we start discuss the question, the 3 questions that you have been given. Okay, here are some tips. Okay, how to make the most of your online classes. Where number 1 is treat each online class like a real class, and then avoid distraction. No Instagram, no Facebook, no TikTok. Okay, and then test run online class platform before each class. Always take notes, ask questions, create a study space in your room, and then create online study groups with friends, and also record classes for future reference. Okay, so some survival guide for you. Maybe you can prepare the hot coffee, planner, headphone, chargers, and some sweet study treats. Okay, now we move to question 1. The first one is calculate the effective resistance of the circuit in figure below. Okay, so we have 1, 2, 3, 4, 5 resistors that is connected in series and parallel combination. So have you tried this question? Okay, so congratulations for those who have did this question. Okay, and also no big deal for those who didn't do this question yet. Okay, we are going to discuss this question together. So how to find the effective resistance for this circuit? We have AB for the terminal, and then we need to start from this one. Okay, from the back of the terminal. So it is a 4 and 5 ohm resistors, and these resistors are connected in parallel. You can see junction here. So 1 over R1 equals to 1 over 4 plus 1 over 5. So we name it as R1. So this R1, we will get it equals to 2.22 ohm. Okay, now we combine it to the next resistors, which is 3 ohm, that is connected in series. So this R1 and 3 ohm connected in series. So R2 is equals to 3 plus to 2.22, which is equivalent to 5.22 ohm. Okay, next you can see that our R2 are connected in parallel with this 2 ohm resistor. So for parallel combination, we use equation 1 over R3 equals to 1 over 2 plus to 1 over 5.22, and we get it R3 equals to 1.45 ohm. And lastly, okay, we have terminal A, and then you can see 1.45 ohm and connected in series with 1 ohm. So this combination, it is connected in series. So RAB will be equals to 1 plus to 1.45, where RAB, the effective resistance for AB, is equals to 2.45 ohm. Okay, so how is it? Is it okay? Alright, okay guys. So now we move to the second question. We have a battery P with EMF 1.3 volt and internal resistance of 2 ohm. So this battery B, okay, have internal resistance. And then battery Q with EMF 1.5 volt and the internal resistance 0.8 ohm. Okay, so battery Q with the internal resistance and a 4 ohm resistor are connected in parallel. Can you imagine how this circuit looks like? So you can see the question asks to sketch the circuit diagram and then calculate the current in battery P, battery Q, and the 4 ohm resistor. After that, we need to calculate the potential difference across the 4 ohm resistor. So, how does this circuit diagram look like? Come on guys, easy peasy lemon squeezy. So, please imagine first before we look at the diagram. So that EMF P and Q is connected in parallel. So this is how the circuit diagram looks like. So we have a EMF and EMF P with internal resistance P and connected in parallel with EMF Q with internal resistance RQ, and lastly it is connected in parallel with resistor R. Okay, is it okay class? Alright, so the second question is calculate the current in battery P, battery Q, and the 4 ohm resistor. So kat sini ada apply Kirchhoff law. Kat Malaysia kita ada TNB dia jaga wire-wire kita ni tak seburuk yang ni. Kat mana awak boleh tengok macam ni? Jiran kita je. Kan dia punya wire ni bersambung-sambung. Company ni datang dia sambung wire. Company lain datang sambung wire. Okay, tapi tengok dekat Malaysia wire kita serabut tak? Tak kan? Secantik je tersusun. Okay, back to the question. Alright, we need to calculate the current in battery P, Q, and the 4 ohm resistor. So, okay, what we need to do is, okay, we label it as IP for the current passing through EMF P, and then for the current passing through battery Q, we name it as IQ, and the current that is passing through R, it is I. So we need to find this IP, IQ, and I. So since we have more than one battery, we are going to apply the Kirchhoff law. Okay, so for the first law, you still remember the Kirchhoff first law? Okay, it is at the junction, the summation of I in should be equals to summation of I out, or summation of I equals to 0. So look at junction A. We can see that IP is going to junction A. That means IP is in. And then look at Q. This IQ is going to point A. Okay, IQ is going to junction A. That means IQ also I in. How about I? So the direction of I is away from junction A. So this I is I out. Okay, the second Kirchhoff law, it is summation of E equals to summation of IR. So we have two loops here. So for this case, I assign both loop with a clockwise. Is it clockwise? Anti-clockwise direction. Clockwise ke anti-clockwise ni? Okay, it is a clockwise. It is an anti-clockwise direction. Okay, for loop 1 and also loop 2. Alright, so we are going to look at the second law for loop 1. So for loop 1, we start with EP. So since the loop is going to the left and it leaves the positive terminal of EP. So this EP should be positive. Positive EP plus 2, the other one E, which is EQ. But look at the direction of loop. The loop is moving to the right and it leaving the negative terminal of the battery. So this EQ would be negative EQ. Okay, so equals to summation of IR. So at loop 1, we have RP and RQ. So we need to add these two R first. Okay, where the current passing through RP is IP, and look at the direction of IP. It is in the same direction with the loop. Loop is going to the left and the current IP also going to left. So that this IP RP is positive value. Okay, so we need to add to another resistor which is RQ. Okay, but we need to look at the sign. Okay, so it should be positive or negative. So the direction of IQ is to the left and the direction of loop is to the right. It is opposite direction of I and loop. That means the sign for IQ RQ is negative. Okay, done for loop 1. Okay, recap back. For the battery, we are going to look at the loop and it leave which terminal, positive or negative. And then for the current, I times 2R, okay, for the voltage terminal of the internal resistance, we are going to look at the direction of current and loop. If it is in the same direction, that means it is positive, and if it is in the opposite direction, means that the sign should be negative. Alright class, now we move to second loop for loop 2. So this is loop 2, so we are going to start with the battery. So the EMF here is only EQ. So loop is moving to the left and leaving the positive terminal of the battery. Means that EQ is positive. So equals to, so we have two resistors, RQ and R. Okay, we start with this RQ first. The direction of IQ is to the left and it is in the same direction with the loop. So positive IQ RQ plus 2. The current passing through R is I. Okay, I will passing through R, and the direction of current I with loop 2 is in the same direction, or both moving to the right. So it will be positive IR. Okay, next we are going to substitute. Okay, substitute the magnitude of the EMF P, Q, the internal resistance RP and RQ. So it is 1.3 minus 1.5, okay, equals to 2IP minus 0.8 IQ. So we rearrange the equation, okay, to make it equals to the EMF. So it will be equals to 2IP minus 0.8 IQ, where it is equals to negative 0.2. So this is for loop 1. Okay, how about loop 2? So we substitute the magnitude of EQ with 1.5 and then 0.8 for RQ and 4 for R, and rearrange the equation, become, okay, IP plus IQ plus I equals to E. So it will be equals to 0.8 IQ plus 4I equals to 1.5. So we have 3 equations just now. Okay, this is the equation for loop 2, equation for loop 1, and equation for the current, where IP plus IQ equals to I. So we need to rearrange. Okay, we need to rearrange. Okay, so IP, IQ, I and E. So no need to use the substitution method. Okay, you can just use your calculator, substitute the magnitude of IP. So for the first equation, it is 1, 1, 1, and your E here, I'm sorry, this one should be equals to 0. Okay, so you need to change this. This one is equals to 0. So for the second equation, it is 2, negative 0.8, 0, and negative 0.2. For the third equation, IP is 0, IQ is 0.8, 4, and 1.5. Okay guys, so please check. Okay, when you change this E to 0, is it IP equals to 0.0186 ampere, and then IQ equals to 0.297 ampere, and I equals to 0.316 ampere. So we try it first. Okay, so the answer for IP, IQ and I are correct. Okay, except for the substitution of E for the first equation. So please change this value. Alright, so now we move to the last question. Okay, for question 2. Okay, number 3, we need to calculate the potential difference across the 4 ohm resistor. So where is 4 ohm resistor? Okay, 4 ohm resistor is the external resistor for this circuit. So how to find the potential difference? Other than use the voltmeter, you can apply the Ohm's law, where V is equals to IR, and we already know the value of I, okay, is equals to 0.316. Okay, we times with R4, and we will get our V equals to 1.26 volt. Alright, okay, done with question number 2. So are you still with me, guys? Okay, here are some quotes. Always remember to fall asleep with a dream and wake up with a purpose. So what is your purpose here? Okay, coming to the Malacca Matriculation College. Of course, we need to achieve for flat. Okay, for flat in academics and also for flat in attitudes. Okay dah, bangun, jangan tidur. So we move to the last question, where the question is about potentiometer. So we have a simple potentiometer where wire PQ has length of 100 cm and resistance of 2.4 ohm. The galvanometer G shows no deflection when the jockey is at X. So here at point X, when we put jockey here, the reading for the galvanometer is equals to 0, where the distance is 60 cm from P. 60 cm from P. By neglecting the internal resistance of the 2 volt battery, calculate the EMF B of the battery B. So we need to find this EB. This EB is equals to what? So how to find this EMF B? Okay, remember when the potentiometer is balanced, EB is equals to VPX. So E here is equals to VPX. Okay, that means we need to find that VPX. Okay, before we find that VPX, we are going to find the current passing through this potentiometer first, where we apply the Ohm's law. V is equals to IR equivalence, where V is equals to 2 volt, and R here, R equivalent is equals to, so from the battery we have R passing through PQ, which is 2.4, and we have another one R, which is the external resistor, that is equals to 1.5. By substituting the values, you will get that I equals to 0.513 ampere. Okay, so from the galvanometer, okay, when the galvanometer reading is equals to 0, EB is equals to VPX. So VPX, we are talking about PX, means that it is equals to I at PX times to R at PX. Okay, so that I is equals to 0.513. We had calculated it How about RPX? Since we have values of LPX and LPQ, we are going to apply this one. Do you remember this one? Where L1 equals to, it is L1 over L2 equals to R1 over R2. So we are going to apply this one. RPX equals to LPX over LPQ times 2 RPQ. Since we have LPX equals to 60 cm and LPQ equals to 100 cm, and given that RPQ is equals to 2.4 ohm. So this EB finally equals to 0.739 volt. Okay, we get 0.739 volt. Alright, okay, good job guys. Okay, for those who are still with me, thank you very much. Okay, so I hope you get a good times, okay, here in College Matrikulasi Melaka. So during your time here, don't forget to drink water, read, write, take notes, listen to music, okay, plan, organize, eat healthy, and also don't forget to take a break. Okay, so hopefully, okay, you will grad the flying colours before you leave this college. So thank you very much. Have a good time. Take care guys. Stay safe. Jangan lupa pakai mask. Assalamualaikum. Bye.